Hi, and welcome to another edition of Admiral Science. I'm your host, Mr. Allen, and today we're talking about thermal energy, and specifically we're going to talk about heat and temperature, and how many people, adults and children alike, confuse the two, heat and temperature, and think that they mean the same thing. And today we're going to say that they mean something different. All right, so let's look at temperature to start off with. Alright, so if we look at temperature, we want to think about temperature as a measure of the average kinetic energy of all the particles in an object. So what that means is, remember about kinetic energy. Kinetic energy is the energy of motion, and so as something moves, it has kinetic energy. The faster it moves, the more kinetic energy it has. The slower it moves, the less kinetic energy it has. Well, temperature is the measurement of that, and the measurement of the average of that. So if we look at our first screen, our first picture, our first diagram, the temperature is at a lower degree, and the particles are not moving that fast. And so when you add heat to this, the particles then start to increase. The particles then start to move faster, and then the heat has caused an increase in their speed, and that speed is also represented by the increase in temperature. So as objects have faster moving temperatures, or a higher temperature, then it has faster moving particles. And speed and temperature and kinetic energy and temperature both are relatively the same. So how do we measure temperature? Well, we measure temperature typically in science. We measure temperature using the Celsius scale. And so water freezes at 0 degrees Celsius and boils at 100 degrees Celsius. Well, in science, we also use what is called kelvins. And the Kelvin scale is simply 273 more than the Celsius degree. So for example, water freezes at 0 degrees Celsius. If you add 273 to that, then water will freeze at 273 Kelvin. And that water boils at 100 degrees Celsius, which is equivalent to 373 degrees Kelvin. Alright, so they are represented because Kelvin is simply 273 plus the Celsius degree. Why is Kelvin so important? Because it gives us a special number. This number is called absolute zero. And what absolute zero tells us is that this is the lowest point on the Kelvin scale. Remember how we said that particles are always moving in constant motion, no matter if it's a solid, liquid, or gas, they're always moving. Well, this is true up until it reaches absolute zero. Absolute zero is the theoretical thought that this is where particles essentially stop moving. There is no movement at absolute zero, right? Which is absolute zero is equivalent to negative 273 degrees Celsius. And so that's absolute zero. The absolute zero is where particles will eventually just stop moving. And then that brings us to heat. Well, what is heat then? If temperature is the average of kinetic energy, heat is that transfer from an object at a higher temperature to an object at a lower temperature. That is heat. All right. As objects have different masses, and they have different temperatures, that means they have different heat. Alright, and heat is represented by two factors. Heat is represented by the mass of the object as well as the temperature of the object, or average kinetic energy. So if the object has more mass and a slightly lower temperature, it relatively has more heat because it has more mass. It will be able to heat up something better than something that has a smaller mass but more heat. Alright, so when an object gains or loses heat, the particles then begin to move faster or slower, triggering a phase change. We talked about phase changes before, alright, how we go from a solid, a liquid, to a gas, and vice versa. Alright, and when we look at our graph here, we see that as objects go from a solid to a liquid, there's a point where the plane levels out. And this is where the boiling point or the freezing points or the melting points, this is where these points meet at. And there's no temperature change. As heat is added, it takes a lot of energy just to do a phase change. And so the temperature relatively stays the same for a degree of time as heat is added and more heat is added and more heat is needed and more heat is needed. Temperatures typically stay the same because it takes a lot of energy to break these bonds and to change their transformations. But from a solid to a liquid, we know it melts. But also remember, as it melts, as heat is added, it melts and then vaporizes. But that same amount of temperature, or that same amount of average kinetic energy, can also do the reverse. It can condense a liquid from a gas to a liquid, or it can freeze a liquid to a solid, at the same time as it can melt a solid to a liquid. Just depending on if heat is being added or if heat is being lost. All right. So that is thermal energy in a nutshell. We have temperature and heat, and knowing the difference between the two. Don't forget absolute zero. Don't forget what temperature is. It's not necessarily how hot something is, but the average kinetic energy that an object has. And remember that heat is simply the transfer of an item that has a higher temperature to an item that has a lower temperature. And in that most times does not mean the object that's the hottest, because just because the object is the hottest, it does not mean that it has more heat. Because if we think about it, if we have a teacup that's 100 degrees Celsius and we have a tub of water that's about 80 degrees Celsius, that tub of water has a better chance of heating someone up versus that teacup that doesn't, because it's going to lose heat quicker. Alright? But this is thermal energy in a nutshell. Please look out for the other videos. Check out the video on conduction, convection, and radiation to understand how the different types of heat transfer. And if you have any questions, please feel free to ask me, leave it in the comment section. Look forward to hearing from you. This has been another edition of Admiral Science with your host, Mr. Allen, and I'm out.